Swayam Prabha. Digital India. Educated India.
Welcome to the course on rapid manufacturing. We were discussing the lecture series on product development process, and based upon the feedback which I have got from students, I have noted down some modifications, which as and when I walk through in these presentations, I will try to add those comments, suggestions, whatever they have given. So, we have been discussing on product and its characteristics, evolution of product development, sequential product development, stages in generic product development process, and now we are more focused towards design specification in the process. So, last lecture we were seeing how do we take customer needs, then convert it into engineering specification, and then what we do is we try to develop conceptual details, and then we go for engineering details, then we will release it for production, and then we go for marketing. So, this is a sequence it follows, right. So, now we will start focusing more on design specification. So, it is nothing but establishing the design specification is one of the most important and difficult. Please understand these two terminologies, you have to keep it in mind. It is an important as well as a difficult element in the overall design process. The design specification both drive and control the design throughout the process. It drives and controls the design throughout the process. If the specification what is given is over ambitious, or if the specification given is loosely given, so then the product development will be a big challenge, or the developed product will not see success. So, the design specifications both drive and control the design throughout the process. They are especially important during the early phase of the design efforts, because as and when you move towards the later stage of product life cycle, money investment is going to be huge, time investment is going to be huge. So, it is better we take a call, do the corrections, modify our design specifications at the early stage. It is especially important during the early phases of the design effort, because they serve as a principal guideline for the project team at this point in the process. The specifications are so critical to the ultimate design capability and its cost that they must be established early in the process. The design specifications need to be specific to a system and component level as also. So, what are they trying to say is it has to be broad, it has to be focused to certain points. So, it has to be liberal. So, it has to be liberal, it has to be up to the micromanagement also it has to do. So, it is a mixture, you should have everything put in the design specification. So, you can have a design specification running for 30-40 parameters. They have to be established using a sound judgment with wide and in-depth, look at it, wide and in-depth coordination among key participants in the process, and with test and analysis support when appropriate. So, this is very important, with wide and in-depth coordination. Although specifications are established to be permanent and inviolated, they should nevertheless be continually reviewed and revalidated during the design process. So, once the specification is fixed, that does not mean that is the ultimate. You should have a scope for improvement. So, that is what it says, to nevertheless be continually reviewed and revalidated during the design process, at least until the design is frozen, to ensure that they continue to reflect the goals and the objectives of the project. So, they should continue, the iteration should continue, reflect the goals and the objective of the projects. To establish the design specification, it is necessary to prepare a list of matrices that reflect the degree to which the product meets the predefined needs. The competitive benchmarking can be used to determine the relationship of the new product to the competitive product. So, whenever you try to develop, that is why I always used to say, do the state of art. So, state of the art search, that is nothing but state of the art search. That means to say, what is available nationally, what is available internationally. You should look at a similar product or almost the same product, and then try to redefine your specification such that you can meet out to the same customers in a better fashion. So, state of the art search is very, very important. So, the state of the art search tells very clearly what are the competitive parts or products available, and then what you can do is you can do a benchmarking of it and try to come up with your product. Once the target values are assigned to the selected metrics and specifications are refined, the next stage, conceptual design, can be started. So, this is a block diagram which talks about design specification. Prepare a list of metrics and then you do a benchmarking and then you try to do a value assignment to metrics. So, here you will have benchmarking should be done internally, it should be done competitive, and it should be done in generic. So, your benchmarking should be done in all the three levels: internal level, within the company, competitive level, and in the generic level. Prepare a list of metrics. Customer needs specified in the previous steps are translated into measurable characteristics that will reflect the degree to which the product satisfies the need. So, it is in a crude fashion, understanding customer need and converting into engineering requirements. So, that is what is measurable characteristics are that. The major assumption here is that the translation from customer need to metrics is possible, and each need can be represented by one matrix. Thus, meeting the matrix will lead to a customer satisfaction. Theoretically, this assumption is valid, but there are needs that cannot be measured or that are difficult to be represented by a single matrix. So, it is very difficult to have a single matrix. So, what we will do is we will try to have a combination of matrix and then try to prioritize and then try to make your prepare the matrix for the specification. So, in this case, engineers can make the assumption that satisfies more than one matrix will eventually lead to satisfying a certain need up to an acceptable degree. A useful tool that can be used when preparing the matrix list is the needs matrix matrix, in which the row of the matrix will correspond to the customer need and the column corresponds to the matrix. A generic need matrix is illustrated in the next slide. So, we can understand more. When a mark in a cell in the matrix indicate that the need and the matrix associated with the cell are related. So, this is how is the need matrix graph look like. Here are the needs, here are the metrics. Okay. So, the needs matrix will represent the relationship between the needs and the metrics and ensures that all the customer needs are considered in this matrix. So, moment you start putting on a piece of paper and start assigning it in a table form. So, you can give more data, you can try to cluster data, you can do more amount of logical interpretation of the data which is available in front of you. So, here the data which is available is need and metric matrix we are trying to develop. Next is benchmarking. Benchmarking is defined as the continual search for the implementation of practices that could provide a competitive edge. That is what is benchmarking. So, we always do benchmarking, and today when you ask a psychologist, they say please do benchmarking with yourself, that last time you performed this, now you should perform much better. That is what they try to do. All the sportsmen are clearly given an instruction that they should benchmark first among for themselves. For example, you are running a athletics 400 meters, first you clock your time. So, it was, for example, it was 20 seconds today, next day if you can do it at 19, 18. So, those are benchmarking improvements which you can see. So, benchmarking, when you talk about sports and individual personality, they say do for yourself, but when you talk about a product, it will always be with the other competitive products in the market, okay, so that you get an edge. Companies differ in the way they implement benchmarking, but it is the usual adopted as a corporate strategy used to identify the industrial leaders, promote proven techniques and approaches, establish meaningful goals, perform business forecasting and analyze the overall internal process. So, corporate strategy is to identify the industrial leaders. For example, you are making a t-shirt. So, in a t-shirt you have buttons. You try to look at the buttons which are available from a successful or from a very successful product or very proven product. You take those buttons and then start looking at what are the problems faced in those buttons, and if you are developing, how is your product superior or inferior to that one. So, that is what is, you always try to compare it with the industrial leaders, promote proven techniques, approaches, establish meaningful goals. You should not copy and repeat the same. When you do benchmarking, you always surpass the standards whichever is available. So, you will try to go more than the products which is available. Perform business forecasting and analyze the overall internal process. Benchmarking can be categorized into three major categories: internal benchmarking, competitive benchmarking and generic benchmarking. When we talk about internal benchmarking, in this type of benchmarking, similar activities in various locations, departments and units are evaluated to gain data accessibility. That is internal benchmarking. Competitive benchmarking, this type of benchmarking is concerned with identification and evaluation of direct competitors to obtain data relevant to the product under the investigation and to find comparable processes to gain competitive edges. This type of benchmarking is concerned with the identification and evaluation of direct competitor. I make a shirt, you make a shirt, I see how better is my shirt than you. So, identification, concern with the identification and evaluation of direct competitor to obtain the data relevant to the product under investigation. So, my shirt, your shirt, and to find comparable processes to gain a competitive edge. My shirt, your shirt, how is my shirt better than your shirt in terms of whatever 1, 2, 3, 4, 5. So, that is what is comparable process. Generic benchmarking, the objective here is to evaluate the organization and their function that are considered to be the industrial standard to achieve procedure standardization. So, generic benchmarking is generally done for industry level. For example, rather than looking at one product, you look at the complete process of the company, complete process of whatever happens. So, the objective here is to evaluate the organization and their function. For example, I am running an education institution, you are running an education institution. How is your institute better than mine? So, what are all the good practices you do, and I try to customize the good practices whatever you do there to my requirements. Okay. So, that is what it is. The objective here is to evaluate the organization and their functions that are corresponding to be the industrial standards to achieve procedure standardization. The last one in the process is value assignment to metrics. In this step, the design team synthesizes all the information acquired to set actual values for the metrics. Two values are usually assigned to each matrix. One is the ideal value, which can be defined as an optimum value that the design team hopes to accomplish, and the other is the minimum acceptable value, which can be considered as the lower limit that can satisfy the need. So, are you able to understand this? I will put you an example. I have a examination wherein which I have to get marks. That is a competitive exam, I am writing it. So, if I wanted to qualify the examination, I should get 60% marks. If I wanted to get a good rank admission in a good school, I have to get 90% marks. So, that is the difference here. One is the ideal value, which can be defined as the optimum value that the design team hopes to accomplish, 90. 90 here is higher, but that is what is optimum if I want to get a good admission in a good college. And the other one is minimum acceptable value, which can be considered at the lower 60 marks in the examination. So, if I get 60, I will get an admission. If I get 90, I will get a good college admission. That is what is given here, value assigned to matrix. Usually, design will progress to achieve a matrix value between the ideal and the lower limit. So, you will, this is the top level, this is the bottom level. So, you will always try to have somewhere around here. This is what designers look out. This is optimum, this is minimum. Designer will always try to designer's value. In all cases, the design team should have the ideal value as their primary objective. After the problem has been clarified and completely described, the viable solutions are identified and optimum approaches are selected. The problem solutions or concepts are defined as an approximate description of the product or technology that meets the stated needs. The conceptual design stage is concerned mainly with the generation of solutions and concepts. So, these are multiple solutions, for example, from moving from x location to y location. I have to go to x to y. So, I can go like this, I can go like this, I can go like this, this and I can go to y. So, there are multiple solutions generated, some are feasible, some are infeasible, but you start generating conceptual ideas, okay, and later you can kill some ideas which do not even come in the optimum viability zone. Okay. So, the conceptual design stage is concerned mainly with the generation of solution, let it be viable, not viable, we are least bothered, that satisfies the need, and it selects a concept that is most suitable for matching the predefined design specification. The major steps that can be identified in conceptual design phases are the concept generation or generation of idea begins with a defined problem statement, which you have already done, that includes customer market need, design specification and ends with several product concepts for which the design team will select the most suitable ones. The systematic procedure is given in the in this slide. So, here you will have problem, formulation, then you will have overall function analysis, then you will have sub function analysis, then you will have function diagram, then after that you will have generation of ideas and solutions. So, these are all the steps which are involved in concept generation. So, first is problem formulation, then overall functional analysis, then sub functional analysis. Say for example, if you take a product, then the product will have subsystems. So, now what you do is these are subsystems. Like that you will have sub function. So, each subsystem is going to do a sub function of the main function, okay, subsystems, and then you will try to, for each subsystem you will try to draw a functional diagram, and then what you will do is you will try to generate ideas and solutions. See the problem formulation: prepare an abstraction of problem to broaden it out and clarify it, so it is easier to understand the important issues. So, in the problem statement you should try to say the issues which are attached. Prepare an abstraction, that is what I told last time also. An abstract has to be done. I need to buy a sweater. So, I can't say please try to buy a sweater. I cannot say. I should try to say please try to suggest a protective layer such that I can maintain the body temperature. If my things should be as abstract and as broad as possible, then there are umpty number of solutions, out of which one solution is wearing a sweater or buying a sweater. I can buy a jacket, I can buy a sweater, I can buy a shawl, or I can come up with, today a lot of technologies are there. So, I can come up with some technology which can keep me internally heated or warmer. Okay. So, you should have it as abstract as possible and as broad as possible, such that you can try to solve the issue. It may be necessary at this point to break the problem down into several easier, understandable and manageable sub problems. That is what we do in mathematics also. Suppose you have some 10 variables which has to be solved. First what we say is we take one variable and say rest of the variables are all 0. So, why? You will try to solve one variable. Then we have solved one variable, then we will go try to take the other variable and then assume all other things are 0. So, like this slowly we will try to take one at a time, start solving one variable, get the solution and then start doing. So, that is what is the same approach is used in the designer also. So, it may be necessary at this point to break the problem down into several easier, understandable and manageable sub problems. The overall functional analyze the overall function by describing what the product or the system is supposed to do. Okay. If I am going to buy a system, I should very clearly say what is this system expected to do. So, once I say this system is expected to do this job, for example, with a car, I am expected that it will help me to move, my mobility is enhanced. The function of an automobile is to enhance mobility. So, that overall function must be very clearly given. It is important here to focus on main functions and to describe functions in general terms as much as possible. Furthermore, action statements in the form of verbs, nouns should be used in representing the function, that is to transform material or to transmit information. So, we have to use this pattern, this is very, very important. Furthermore, action statements in the form of verb noun should be used in representing the function. Sub function analysis, as I told you, main function divided into several small functions such that it is easy to solve. The overall function is now broken down into several small functions necessary for the product or the system to operate. For example, I was recently amazed because there is a shirt which has buttons and you have to wear the shirt like a t-shirt. So, that means to say along the shirt you will have buttons, all these buttons are just placed, you can't open the shirt, it will be a t-shirt. So, every time you have to use the t-shirt and you have to wear it from the top, right. So, now if you see a shirt which is now blunt, which looks like a shirt, but it is a t-shirt, right. Now, if you see what do you expect from a t-shirt, then you will try to write down all these statements, right. You will try to say I expect the t-shirt has to do this action, the t-shirt button should not fail, or the t-shirt should have it should try to absorb all the sweat. So, all these things are there. So, earlier we were trying to talk about a shirt t-shirt, right, which is only to protect you, to give a glamorous look or to give a very gorgeous look. But now slowly after that is over, then what you do, it has to give me cool comfort, it has to absorb my sweat, it has to be as drapable along my body as possible. So, all these things come into picture. Why did this t-shirt shirt come is, it came because of the drapability property. T-shirts are drapable, it tries to take a shape of your body, and shirts to some extent yes, but predominantly it tries to have a pre-structured shape in it. Okay. So, now what did we do? Shirt, t-shirt blend, the function was to give a rich look, but later then when you see it is used for, you have added several more subclasses to it, so that it can be used in the fullest form. So, the overall function is now broken down into several small functions necessary for the product or the system to operate. The sub functions, when reassembled, should support and lead to the accomplishment of the overall function. The sub function should not dictate, and sub function should not be independent. The success of a sub function should lead to the success of the overall function. Sub functions may be thought of as a specification or requirements imposed on the overall function. This is also very important. Then functional diagram. Functional diagram is represented as a function structure in which the function under study is represented by a block, and the input output are represented by arrows entering and leaving the block. Okay. So, the function diagram is a representation of the function structure in which the function under study is represented by a block, and input and output are represented by arrows entering and leaving the block. Generation of ideas and solution, which is the last part of it. At this step, ideas and solutions of the sub functions or the sub problems are first generated. So, we try to solve each sub problems, each sub function, and moment you start solving each sub function, we have already made a relationship diagram that if I solve this for sub function, my overall function of the system is going to become okay. So, the sub problems are first generated and combined together to form the overall function or to solve the overall problem. The ideas and solutions can be generated using different techniques. So, one technique is brainstorming technique. In brainstorming technique, we follow concurrent engineering. So, a lot of people sit together and then think of variable solutions to solve the problem. A development team can use brainstorming in which a group of participants generate in a set period of time. Please understand, brainstorming is not infinite time. In a set period of time, many ideas that can be used to solve the problem. They sit for half an hour, they sit for 1 hour, keep talking, and finally, if they do not get a solution for the problem, they stop the discussion and then they take a break. They say, okay, today we are not able to get any solution for the problem, so let us stop, but let us keep pondering, let us meet tomorrow. So, then the entire team comes tomorrow and again they start pondering it. Definitely there will be a delta x improvement. Again, if there is a failure, no problem, they come for the third day, but they do not sit together for 24, 48 and 72 hours and try to get a solution and move. No, they break, so that every time when you come up with a fresh thought, fresh idea, and then we relook and then we do a brainstorming session. In brainstorming session, what happens? It is not that one man's idea is fully accepted. Many a times it will be a cut paste idea of several participants in the group giving the solution. Brainstorming session usually aims at producing a large quantity of ideas irrespective of their quality. They do not look whether it is feasible or not feasible. First write down all the ideas which comes, write down, and then what we do is, okay, then we start putting a full filter or a lens, we start looking at it, and then we cut down all those things which has not serving any purpose. Also, the development team can search published literature, patents, catalogs for possible solutions. Interviewing user can trigger some ideas for the solution. A good practice in generating ideas is to try to reuse existing solution of the products in solving new problems. What is known to you, what is your expertise, use that, tweak that, customize it and try to solve for the particular problem. How do you select concepts? Because you have generated so many concepts. So, now the selection of this is very, very important. Concept selection is a process of evaluating and comparing alternative concepts with respect to customer/market needs and design specification, leading to the selection of the most suitable one or a set of concepts for further investigation or development. Concept selection can be the toughest job also. See, in design, every stage I say it is tough, but concept selection is also really tough. Many a times, ultimately they take a judgment based upon their gut value. Some designer comes say, hey, I think it will work, maybe why don't we try? It starts working. By accident also lot of technology is developed, lot of interesting products developed. So, it happens. Okay. So, you should give values, sometimes you should also give values for the gut feel what comes to you. Okay. So, this concept selection is something great, because it is like a menu card. You have generated so many items and all those items are listed in a menu card. Now, you are going to a hotel in a hungry mood. So, looking at the menu card, you have to spend 10 minutes of time and pick exactly what can suit you for that hunger. If you go by random choice and do, your stomach will be full, but you will not feel happy and comfortable after eating and after even paying. So, concept selection is something you have to put prudence, you have to see the feasibility, viability, customer wants, market demands, everything what you do is you put together, look at your design specification and then try to make a proper choice. The concept selection can be performed according to the following guidelines given. So, first is select solution principles, then we try to do design concepts, then we try to do technical evaluation. Then we do economic evaluation, and finally, we select final concept. Okay, these are the steps which are involved. So, first is select solution principle, and then you start looking at design concepts, then you evaluate it technically, and then economical evaluation is done, and finally, we try to select a process. So, select solution principle, the suitable solution principle that can satisfy the needs are selected individually or in combination with other solutions. The selected solution should be able to perform the required function effectively and efficiently. Combined solution principles into complete design concepts. So, what they say is they try to combine design the solution principle. There are several principles we follow and that everything is combined into a complete design concept. The selected principle in the previous step, whatever we select in the selection of principle, are arranged into a complete conceptual design that corresponds to the overall function, that is concepts that correspond to the sub functions are arranged together to form a large concept that can be accomplished in the overall solution. So, the selected principle in the previous steps are arranged into a complete conceptual design. The principle, selected principles that corresponds to the overall function, that is concept that corresponds to the sub function, are arranged together to form a large concept that can be accomplished the overall solution. Evaluation concept technical is that concepts are now evaluated with respect to the degree to which they meet the designer specification. The concepts that do not meet are eliminated. With keeping economics, concepts are evaluated with respect to their cost, that is concepts are investigated for their economic feasibility. Non-feasible, we drop it here. Select final concept. A final decision must be made among the technical, economical in the previous two steps, feasible concepts by utilizing the scoring techniques that incorporates all the customer needs and satisfies. So, the final concept preliminary design, this step of the design process bridges the gap between the conceptual design phase and the detailed phase. So, this is final concept preliminary design. The final concept is further defined during the steps. The overall system configuration is defined and a schematic diagram, definition drawing or the other engineering documentation is developed to provide early project configuration control. So, other engineering documentation is developed. System level and to the extent possible component level design requirements should be established during this phase of the design process in a manner that corresponds to the design specification of the previous definition. So, this is also very, very important. System level and to the extent possible component of, that is what I said, be as liberal as possible, give 25-30 specifications for a small component. So, system level you give all and you also make sure it is given to the concept level also requires should be established during this phase of the design process in a manner that corresponds to the design specification. So, the detailed design is a part of the design in which starting from the concept to the technical report, a technical product, the design is developed in accordance with the technical and economical criteria. At this phase, the design concept is resolved into component parts. Components are evaluated to validate previously established requirements and the effect of the component requirements on the overall system requirements is evaluated. So, you see here the design concept is resolved into component parts and the components are evaluated to validate previously established requirements and the effect of the component requirements on the overall system. So, you see here, so design concept is resolved, is broken into component parts and these components are evaluated for validate to previously established requirements and the effect of component requirements to the overall system. Okay. So, all the arrangement, form, dimension, surface properties of the individual parts are finally laid down. If I want to make a system, it will have subsystem. The subsystem will have parts. Now, the parts should be made to such a level such that once it gets into the subsystem and once the subsystem gets into the main system, it should be able to perform its task, whatever it was supposed to do from the customer requirement. Suppose if I make a mistake in the part or if I do not do the part properly, naturally the sub function is not going to function, and if the sub function does not function, the main function is lost. So, that is what is told here. All the arrangement, form, dimension, surface properties of all the individual parts are finally laid down. The material specified, production possibility assessed, cost estimated and all the drawings and other production drawings are produced. The intent of detailed design phase of the project is to develop a system of drawing and specification that completely describes a proven and a tested design, so that it can be manufactured. This is very important, to develop a system of drawing specification completely describing a proven and tested design, that only can be, so that it can be manufactured. So, here we will have component final design, which will have cost estimate, and this will lead to prototyping. Whatever you develop, finally cost component has to be added to it. So, component final design will lead to cost estimate to prototyping. So, component final design, the overall product concept generated in the previous step is now designed by designing its components. The components are designed to meet the product specification identified earlier. The results of the component design should be component specification list, which in most cases will be part of the overall product specification. So, individual product specification whatever you give, it makes sure that the overall function is also met. The component specification in general will contain a list of all the necessary information required to procure or manufacture. The component such as operating parameters, component dimensions, materials are all given in a detailed design. The component final design is represented in several documents such as detailed drawing, assembly drawing and bill of materials. And those of who are not mechanical, they will not understand bill of materials. Bill of materials is nothing but the list of all parts which are getting into the final product to be made. The cost of producing or developing a selected concept product is estimated from the costing. Justification of the trade off considered must also be included in this study, and once it is all done, then we try to make a functional prototype model of the product at this point. So, further investigation concerning the actual functionality and appropriateness of the product developed can be made on this model as a final step before starting production and introducing it into the market. So, the next step is production. The production planning aims at constructing a production plan that uses the available machinery to produce products effectively and efficiently. The process plan begins with analyzing the detailed design documentation, which includes information about the product geometric features, dimensions, tolerance, material and surface finish. This information is treated as the target that must be met. So, when it comes to this level, the customer will not even realize that are we demanding these drawings, are we demanding these specifications. The customer will look at only the end functional part, right. So, from there you see concept evolution, detailed and then from the detailed design only production can be made, because the detailed engineering release whatever it says, it gives you all the drawings, assembly drawing, it also give you part drawing, and from the part drawing you will try to see whatever it is. The process proceeds to identify the appropriate machinery capable of achieving the design target. The sequence of operation is also identified. In production, there is nothing called unique solution, nothing is unique. So, you choose looking at the machines available, looking at parts available, looking at the constraints available, you try to choose a feasible solution. The design for manufacturing and assembly is an important concept used in the production phase to gain greater insight about how the production design interacts with the manufacturing system, and uses this knowledge to design better quality products that can be produced for reducing the cost and producing it in a faster time. So, it is nothing but the life cycle time is reduced. The design for manufacturing and assembly will identify the product design alternatives that will facilitate the optimization of manufacturing system as a whole. So, the production follows some generic rules or guidelines. Simplify the design as much as you can. The design should be simplified before production automation can be considered. If the design is very complex, then automating it becomes very difficult. So, if you are thinking of automation, make the part drawing as simple as possible, make it symmetry, make it you have a mirror image of it. So, all those things are simplifying the design. The product design should be made with automatic assembly in mind. See, automatic assembly, what it does is, automatic assembly does not try to have multiple axes of approach in making assembly. For example, if you take PCB, it will all be in one direction, only from the top to bottom. Gravity will be used as a force of advantage, and the entire assembly happens. So, when you think of developing the design itself, try to think of developing very simple and parts which will be automated later. Eliminate operations through required skill. Effort should be made to eliminate manufacturing tasks that require special skills. So, do not make tighter tolerance, do not try to have a complex freeform surface, try to make it as simple as possible. So, even a semi skilled labor can be used to make those parts. Number of parts has to be reduced. So, if the number of parts are reduced, assembly time is reduced, number of parts are reduced, reliability is increased, and then maintenance is reduced. So, the parts used in a certain product should be those that are critical for the product to function appropriately. It is necessary to design parts that perform several functions. So, it is a single part with multiple multiple features. Okay, multiple features. So that each feature can do several functions. Reducing the number of parts will decrease the production cost significantly. Use modular design. So, modular so what is so system subsystem. So, if you can use some subsystem which is commonly available in the market, for example, the adapter for laptops, it is commonly available. If you make it so specific only to your laptop, then sorry, you will not be able to get you will not be able to attract the market, right. So, batteries which are used for several domestic applications, the batteries will be AA battery, AAA battery, whatever it is a standard size, it is modular in nature. Okay. So, it is easier to automate the production of modular products, use standard parts, use multiple function design. So, these are some of the guidelines which are given in the production or in the design for manufacturing. So, the last step is manufacturing, the last step is marketing. Marketing is, although the design engineers are not involved directly in product promotion and distribution, the information about problems that occur during marketing and distribution of the product should be integrated into the product design. The design engineer should design packaging to protect products from damage during transport and storage. Design engineer can also be involved in the promotional activity by interpreting customers' question and criticism about the product and relate them to the design specification. So, you see, from the criticism and the customer question, you relate it to the design specification. This will enable the design engineer to modify the product design and improve it to the corresponding needs. So, in this lecture series of product development, we saw what is a product and what is its characteristics. We saw how can you think of evolution of a product development. Then what are the 4 logical group of activities which are generally there. What do you understand by sequential product development? What are the stages that are in generic product development? How will you consider design specification in designing? What do you understand by conceptual design and generation selection? So, these are the things which we saw in this lecture. So, now a small task for the students which you do not have to submit. List down at least 10 products which follows modularity concept. Okay. Write down their advantages of using modularity. Okay. The third question is, take any one product and try to standardize the parts used in it. Try to standardize the parts used in it and make an analysis of the part working. So, you take a part which has lot of non-standard things, and then you put standard parts, and then you see what is their performance and other things. Okay. The last one is, try to do a customer voice analysis on a problem which he she faces daily. It can be anything, mobility, it can be mobility, it can be taking heavy loads to the school, a huge baggage of books and notebooks taken to the school, and walking a long distance, cycling a long distance, and then preparing food after coming up after travel. So, these are some of the problems which are there. So, all I want is you talk to your customer, whomever you feel like, and understand what is his problem which he faces daily, and try to look for a solution for it. Okay. So, with this 4 problems whatever I have given, these are all tasks. So, you try to solve this and then come out with a solution, so that you yourself will do. The 10 products which I have listed, you can take up even a ballpoint pen, you can take a battery, you can take a torch, you can take a mobile phone, you can take anything, then write down their advantage. What is the advantage because of modularity you are enjoying in it? Take one product and try to standardize, that is what I told you. Try to take a product which uses non-standard things, and you try to put some standard parts, and then try to see what is the efficiency of the product. Then customer's voice. With this, I come to an end of this section of the lecture series on product development. So, we will continue next with another topic. Thank you very much.